Hey there, STEM Chemistry. This is Ms. Ruark. We're going to start, now that we've learned the basics to bonding, let's start talking about how to name these compounds so that when we actually get into bonding and we get into chemical reactions, we can say the correct names. And when I say the name, you know what I'm talking about. That helps. Okay, so ions and formulas. By predicting the formation of ions, you can determine the formula of a compound. All right, so example, what would the compound be if we had calcium and oxygen put together? Well, calcium from the periodic table makes a +2 charge, and oxygen makes a -2 charge. Okay, so how do we figure out what the formula of this is? Well, remember that an ionic compound means it has a metal and a nonmetal. And if it's a metal and a nonmetal, it's going to be a ratio in the simplest form of those ions. So the ratio here for calcium to oxygen would be a 1-to-1, because if I had one calcium with a +2 and one oxygen with a -2, the 2's would cancel each other out and make it a neutral compound. So my formula for this compound would be CaO. All right. Oh, look at that. I'm going to erase this because you've already seen that. All right, so here's some steps to writing the formula. You write down the charges of the ions, you cross down the charges, and then you simplify the formula. So let's do some practice. We have aluminum and bromine. Aluminum has a +3 charge. Whoa, that was weird. And bromine has a -1 charge. So you write down your charges. You're going to cross down those charges. Now you're taking the absolute value of these, so the pluses and the minuses go away. Absolute value. Okay, so the 3 comes here, and the 1 comes here, and we get Al1 Br3. However, and I don't have it written here, in chemistry we don't really write the 1's, we just assume. So you take away the 1 and it would be AlBr3. Can I simplify the 3 and the 1? No. So there you go. All right, what if I have K with a +1 charge, and I have S with a -2 charge? When I cross those down, the 1 comes here, the 2 goes here, and so we have K2S1. Can I simplify? No, so we get rid of the 1, K2S. All right, I want you to pause it real quick and do C, D, E, and F, and then come back and check your work. Yes, pause it. Pause it. All right, Zn has a +2 charge. Zinc only has a +2 charge and nothing else. And then we have oxygen with a -2 charge. When we cross those down, we get Zn2O2. Can these simplify? Yes. Pull out your greatest common factor. I think that's what it is. All right, and so we end up with ZNO. All right, Mg with a +2 charge and N with a -3 charge. Cross those, you get Mg3 and 2. Can I simplify? No. All right, C with a +4 charge, or actually it's a plus or a -4, right? Oh, okay. And this is a tricky one because this actually isn't an ionic compound. So I tell you what, let's come back to that one. We'll come back because that's not an ionic compound. Not fair, Ms. Ruark. All right, and then copper here. Copper can have a +1 charge, and copper can also have a +2 charge. Oxygen, can only have a -2 charge. All right, so when we cross these, if it was copper with a +1, we would have Cu2O, and if it was copper with a +2, we would have Cu2O2, which simplifies into CuO. So either one. We just didn't designate, so you would give me both. All right, naming ionic compounds. So the name of an ionic compound will always end in IDE. So for example, sodium chloride, the metal or the positive ion comes first always, we don't name it chlorine sodide. That doesn't make any sense, right? NaCl. We don't name it chlorine sodide. That really doesn't sound right. So the positive ion always comes first, positive, negative always comes second. And we don't capitalize it unless we're starting a sentence. All right. So examples, given the formulas and the names. So calcium would have a +2 charge, and iodine would have a -1 charge. When we cross those down, we get CaI2, and this would be calcium iodide. Excuse me, I have a cold. All right. Oxygen has a -2 charge and magnesium has a +2 charge. But Mr. York, you said the positives have to come first. That's right. So rewrite it with the positive first. Why? So you don't forget. Because yes, you will forget. All right, cross those down. We end up with Mg2O2 that simplifies into MgO, and it would be magnesium oxide. And then for this last one, Na with a +1 charge, S with a -2, cross them down, you end up with Na2S. Can I simplify? No. So it's now sodium sulfide. Pretty easy, right? Yes. Okay. What if it's a transition metal? So if it's a transition metal, the way that we name them, we change the anion ending to IDE still. We show the charge of the metal in parentheses using Roman numerals. You really don't need to know all of them. You just need to know 1, 2, 3, 4. That's a 5. Let me rewrite that. 5. And maybe 6. Okay? But those are the ones you need to know. 1, 2, 3, 4, 5, 6. Okay, so for copper with a +1 charge, we would write it as Cu1. And we're showing that the charge on the copper, whatever comes in parentheses after it, is the charge. And now I told you that we don't write ones. This is the exception to the rule, right? Everything in chemistry is an exception to the rule. Yes, always. So when we write the Roman numerals, you have to write the 1. You have to write the 1. I'm going to go ahead and answer that question now. All right, so copper 2 would be Cu with a 2 as Roman numerals. Okay, the number refers to the charge, not the number of atoms. All right, so names and formulas for the following compounds. If we have copper with a +2 charge and chlorine has a -1 charge, we would cross those and get CuCl2, and the name of this would be copper 2 chloride. Okay, what about CO, cobalt with a +2, and chlorine has a -1, so we would cross those down and we would get CoCl2, and it would be cobalt 2 chloride. All right, go ahead and try these last two, and we'll check them when you get to class. Okay, transition metals. The other way you can name them is the classical or the old way of doing it, which we don't really do, but I'm going to teach you anyways because it's always nice to know because they do use both. So you're still going to change the N to IDE. The metal is named with its Latin or English root. Okay, and I say Latin or English because those are the majority of them, but some of them come from others. And it ends in either IC or OUS to denote the charge. So IC is higher in charge than OUS. Okay? Yes. All right. So for example, Cu with a +1, copper used to be cuprous. Okay? Copper would be, for copper 1, it would be cuprous, and for copper 2, it would be cupric. Okay. And there are a bunch of other ones. They are here. I will give you a list of these. They will be in your vodcast notes, but you probably won't be able to see them that well. Okay, so I will have a list of these for you just so that you have them in case you need them. All right, so if we were to give the Latin names in the formula, so copper with a +2 and chlorine with a -1, we cross those down. It's CuCl2, and because it's copper with a +2 charge, it's going to be cupric chloride. Yes. And this, my friends, is not fun and it's not easy, and that's why we don't really use it that much anymore. Okay, but you still got to know it. All right, CO with a +2 charge. You can have cobalt with a +2, and you have cobalt with a +3. Remember, this one's going to have the IC. This one's going to have the OUS at the end of it. So when we cross those, we get CoCl2, and it would be cobaltus. Cobaltus chloride. All right, and we'll do some more practice with these in class as well. All right, polyatomic ions. So what is a polyatomic ion? It's a group of atoms that can have a charge. Okay, so a polyatomic ion, polyatomic ions, I write them as PAI. Okay, polyatomic ions. So if you see me write it this way, that's what I mean. It's a group of atoms that have a charge that act as a single unit together. Okay, so examples of these would be OH, which is hydroxide, and SO4, which is sulfate. And then here is a compound that has PO4, which would be phosphate. All right, so naming the following compounds with the polyatomic ions. OH is hydroxide, and I will give you a chart with these. It actually might be on the back of your periodic table, so check. And SO4 is sulfate, okay? And then CO3 would, there's not supposed to be a CO3, it's CO2. CO3, yes, CO3, sorry, brain fart. Carbonate, and then NO3 would be nitrate. Okay, so to name, oh, and NH4 is ammonium. All right, so if you name these, all you're going to do is just the same. You don't change the end of the polyatomic ion, so it's going to be calcium hydroxide, and that's it. That's it. Don't change it. Okay, NH4 is a polyatomic ion. Those stay together, and NO3 is a polyatomic ion. They stay together. So this is ammonium nitrate. Here we have copper, and copper, you would say, well, I don't know what charge it has. Well, I'm going to show you in class how you figure out the charge. SO4 is sulfate, and sulfate always has a -2 charge. And to cancel out the charges, copper has to have a +2 charge. Okay, you're probably like, what? And that's okay. We'll do some practice on this in class. So this would be copper 2 sulfate. Now, if you want to be adventurous and you want to name it with the Latin name, it would be cupric sulfate. Your choice. All right, and then for this one, cobalt carbonate always has a -2, and cobalt has a +3. How did I figure that out? Well, I took my subscripts and I crossed them up. All right, so it's going to be cobalt 3 carbonate. And again, if you're kind of iffy on this, don't worry, we're going to practice more when you get to class, okay? All right, writing formulas from names. So to write the formula from the name, you identify the ions and the charges that are involved. Cross up the charges, cross down the charges to write the formula. Use parentheses around polyatomic ions. So for this one, sodium, let's do one that you know. Let's see, iron 3 means that it's going to be iron with a +3, and hydroxide is OH with a -1 charge. We know that because it was on the previous slide. All right, so we've got our ions, we've got our charges, so we're going to have to cross these down. Before you cross them down, you need to put your polyatomic ion in a force field. Yes, a force field, because I am a sci-fi Star Wars nut. Okay, so put it in a force field. That way nothing can get inside. Yes, okay, and then you cross down. The 3 comes down, the 1 comes down, and we rewrite this as Fe1OH3. Okay, does that cancel or does it simplify? No, but we can get rid of the 1, so FeOH3. Okay, barium fluoride, Ba with a +2 charge. Fluorine is a -1 charge. We don't have any polyatomic ions, so we just cross them down, and it would be BaF2. Okay, all right, see if you can try the rest of these if you have them on your back of your periodic table, and if you don't, we'll go through them in class. Just remind me when you get there. Okay, and then here's some practice. So I want you to do these for, just try these. Try them. That's all I'm asking. I'm not asking you to be perfect. I just want you to try them, okay? You can use your book as a resource. I'm sure there's a list of polyatomic ions in there as well. I will have a paper with polyatomic ions for you if they are not on the back of your periodic table. And when you come to class, we will check all of these together, okay? And then because, oh, come on, sad face. Because we are in the middle of bonding. Where'd my little thing go? Come on. There you go. I thought this would be cute. Coulombic attraction and all. Okay. I will see you in class.